So in this video, I'm going to take you through the beginning of chapter 10, which is about volume, which is not the same thing as just turning up your phone. This means how much space is in a solid, like a rectangular prism. So if we filled it, just think of filling it with water. That's the volume. Triangular prism, square pyramid, right cylinder. The one that I get most questions about is this one at the bottom, the oblique cylinder. One example of this is in our classroom, the chairs, the legs are actually oblique cylinders. So it doesn't really change the way you find the volume. It's just kind of everything is just shifted, but the volume stays the same as if the cylinder was upright. And that's what I mean by right cylinder. It's just upright. It's up and down at a right angle. So then we have rectangular prism, probably the easiest one. And basic concept, just count all these cubes and you would count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Now, obviously we don't want to do that every time. So there's a shortcut. Take the dimensions and multiply them together in any order you want, and you get that same 24. And then we say cubic centimeters because we multiplied 3 dimensions together. Another one, definitely don't want to count these. So just do 8 times 3 times 12. And it's very easy to calculate. Again, this one, 10 times 10 times 30. And we get 3,000 cubic centimeters. And that's how you would say it. Okay, on to the volume of a right triangular prism. So this one, a little bit trickier to think about. If we find the area of this triangle, which would be pretty easy at this point, base times height divided by 2 is 24. Now, if we start stacking these triangles on top of each other, we would fill out this entire shape. And how many triangles would we stack on top of each other? We could think of it as stacking 12 of them. So we need to multiply this by 12. The 10 is really just kind of there to confuse us. So the area of this, the volume of this is just going to be 24 times 12, 288 cubic centimeters. Let's just say centimeters are the units again. So maybe you're like, well, maybe is there a shortcut? Could I just do like length times width times height, 6 times 8 times 12, and divide by 2? And actually, yeah, that does work in this. Since this is a right triangle, if we do 6 times 8 times 12, that would give us the area of a prism, a rectangular prism. So then if we cut that in half, divided by 2, we of course would get a right triangular prism. So there's a little bit of a shortcut on, if you think of that as a shortcut. Okay, next one, trapezoidal prism. So this one's a bit trickier because if we find the area of this bottom and we stack them up, it's not going to be consistent throughout. So that's not going to help us. We're going to have to find the area of the shape, which is consistent throughout, which is this trapezoid, and we're stacking it this way. So if you kind of put this part on the bottom, then 10 would be the height. So we need to find the area of that trapezoid. And in general, when you're finding volume, there's not really a formula for every single shape, but in general is to find the area of whatever the base is that is consistent throughout the entire shape, and then times the height. So like I said, we kind of have to bump this one, take this trapezoid and make that like flat on the table. So then this 10 would be the height. So that's 10. And the area of the base is a trapezoid. So we need B1 plus B2 divided by 2 times H, which we got from chapter 8. So base 1 plus base 2, 8 plus 4, times the height, which is given right here, it's 5, divided by 2. And then all that times 10. So 8 plus 4 is 12, And then we can kind of make this easier by hand by cutting this in half. 6 times 5 is 30, and then times 10, 300, let's just say centimeters again for the volume. Okay, cylinder. Again, think area of the base, which is a circle, times the height. That's all we got to do, because we're going to find the area of this circle and then stack them up on top of each other 15 times. So area of the base is pi r squared. We're given the radius, 64 pi times 15. So then we can go to our calculator. If you wanted to give like exact value in terms of pi, we just do 64 times 15. You could say that. But then to round, this is going to be 3,115.928 and so on. So I'd probably have you round to the nearest whole number, and then don't forget the units. Okay, that is it for this first section.